Hey Chem students, Mrs. Hartman, and I want to talk to you about mole ratios that exist in balanced chemical equations. And these are really handy because it allows us to determine how much product we can find in a reaction. So if you have a reaction that's going to occur, you want to know how much you're going to make. It's kind of like baking. You may have seen a few analogies to baking in chemistry so far. And if you think about it, when you want to bake something, if you're going to make a recipe, you need to know how much it yields, how much it makes, so that you know, are you going to have enough? And the same thing happens in chemical reactions. How much are you starting with? How much are you going to make? Are you going to make enough of what you need? Because ultimately, when we run chemical reactions and things like that, we are making a product for use. At this point, it feels like we're just making it to make it, and in a way we are. But ultimately, the point of chemistry is to make products for our use. So let's do some examples, and this is what you're going to be seeing in lesson 9.1. And so these are some other examples besides what you're going to get in the soft chalk lesson to help you. So with mole ratios, the most important step for any mole ratio conversion calculation is that you have a correctly balanced chemical equation. Without it, it's not going to work. So I've got 3 examples here, and the directions are to first write balanced equations for each of the following exercises, and then we're going to actually solve the questions and determine how many moles we're going to get. So let's take a look at number 1. We have sulfur, which is S, is burned. Anytime something's burned, that's a combustion reaction. So O2, oxygen, is our other reactant, and it's going to produce sulfur dioxide. And if we take a look at that reaction, it's already balanced. There's 1 sulfur on the left and 1 sulfur on the right. There are 2 oxygens on the left and 2 oxygens on the right. So now, in part A, we have 1/2 mole of oxygen, and we want to know how many moles of sulfur dioxide that's going to yield. Well, if you watched the tutorial on dimensional analysis, you learned about conversion factors. And conversion factors can also be mole ratios. So they are the coefficients of the balanced equation. So in this case, the coefficient is 1 O2 to 1 SO2. So that's going to be our conversion factor. So always start with what you're given. So we're given 1/2 mole of oxygen. And then I want to get rid of moles of oxygen, so I'm going to put them on the bottom here. And I want to get to moles of SO2, so I'm going to put them on the top. And all I have to do is plop in my coefficients. So the coefficient of O2 is 1, the coefficient of SO2 is also 1. And so I find that I produce 1/2 mole of SO2. So my answer would be here 1/2. Okay? Let's try it for 3 moles of oxygen. So this time, if I have 3 moles of oxygen, and this time it's asking me how many moles of sulfur am I going to need to use in order to make this happen, okay? So again, I'm going to drop my moles of O2 down to the bottom, and I'm going to put moles of sulfur on the top. And again, we have a 1-to-1 ratio. We have a coefficient of 1 for S and a coefficient of 1 for O because there's nothing written there. So this would lead me to need 3 moles of sulfur. So my answer here is 3. Simple enough? Let's try it when we don't have coefficients that are all 1-to-1 ratios. Okay, so let's try a reaction between hydrogen and nitrogen react to produce ammonia, which is NH3. Hydrogen is one of our diatomics, so it's H2. Nitrogen is also diatomic in nature, so it's N2. And it's going to produce H3. So now we need to balance our reaction. Okay? I'm actually going to start with nitrogen. If you start with all elements that are not hydrogen or oxygen first when you go to balance the reaction, that's really helpful. It makes it a little bit easier. So I usually do anything that's not oxygen or hydrogen first, then I do hydrogen, and last I do oxygen. And a lot of times the reason you do hydrogen before oxygen is because if water is involved. That's kind of your kicker. So 2 nitrogens on the left, there's only 1 on the right, so I need to put a coefficient of 2 out front. And now I've got 2 hydrogens on the left, and then I take this coefficient of 2 times 3 hydrogens in the chemical formula, gives me a total of 6. So that means I need a coefficient of 3 out front here. So now I have my new ratios, okay? So let's take a look at this first one. I have 3 moles of hydrogen, and I want to know how many moles of ammonia that's going to produce. So 3 moles of H2, and I'm going to drop my moles of H2 down to the bottom, put moles of NH3 on top, and bring my coefficients in. So 3 moles of H2 and 2 moles of NH3. And I see then that I produce 2 moles of NH3. Okay, scroll down just a little bit here. Not quite that much. Doesn't want to do it. Okay, let's try the second one. This time I have 15 moles of hydrogen, and I want to know how many moles of nitrogen do I need to react 15 moles of hydrogen. So moles of H2 on the bottom, moles of N2 on the top. And again, I drop in my coefficients, 3 for H2 and 1 for nitrogen. And I do my math, and I find that I need 5 moles of nitrogen. Okay, hopefully this isn't too complex. Let's take a look at number 3. Aluminum sulfate reacts with calcium hydroxide in a double displacement reaction. Ooh, so now we also have to find our products. But sometimes you can get some clues from the rest of your problem. And if you look here, we see that there's a clue, and that is asking us about calcium sulfate. So we know one of our products then has to be calcium sulfate. So let's write our balanced reaction. Aluminum sulfate. Okay, so aluminum has a charge of +3 and sulfate has a charge of -2. So that means I need 2 aluminums and 3 sulfates to balance the charges. And if you haven't seen this before, I'm going to show you a trick. If you're still struggling with writing chemical formulas. If I write out my ions for an ionic compound, this only works for ionic compounds, okay? And I'm going to ignore the plus and minus sign. So you see I'm deleting those. And then I'm going to drop my charges down in a crisscross manner. I will always get my formula as long as this is the lowest whole number ratio. So if this were like 4 and 2, I'd have to reduce it down to 2 to 1. Because ionic compounds are also empirical formulas, lowest whole number ratio. But this little crisscross trick, it'll always work. Okay? So let's erase all of this here. So that way we have room for our reaction. Okay, so aluminum sulfate, calcium hydroxide. Calcium is +2, hydroxide's -1, so we need 2 hydroxides. Yields, okay, double displacement reaction. That means that our anions are going to swap spots. So that means that aluminum and hydroxide are going to get together. Aluminum plus 3, hydroxide minus 1, so we need 3 hydroxides. Calcium sulfate are going to get together. Calcium's plus 2, sulfate's minus 2, so just 1 of each. All right, let's balance a reaction. And because we don't necessarily have oxygen or hydrogen by itself this time, they stayed in their polyatomic ion forms, so we can just go right across the reaction if we want from left to right. So on the left we have 2 aluminums and we only have 1 aluminum on the right. So I'm going to put a coefficient of 2 out front. For sulfate, I have 3 sulfates on the left and I have 1 sulfate on the right. So I'm going to put a 3 out in front here. And so now I have 1 calcium on the left and I have 3 calciums on the right. So I need to put a 3 here. And here I have 3 times 2 is 6 hydroxides, and here I have 2 times 3 on the right, 6 hydroxides. So this is now a balanced reaction. All right, part A. We have 10 moles of aluminum sulfate. 4, 3. And I want to know, I think I wrote the answer in actually. Yep, I did. It should be just blank moles of calcium sulfate. Okay. Let's drop down our moles of aluminum sulfate. AO2, SO4, subscript 3. To moles of calcium sulfate. And again, pull those coefficients in. So out in front of aluminum sulfate, we don't see anything. That means an assumed coefficient of 1. And for calcium sulfate, we have 3. 10 times 3, 30 moles of calcium sulfate. SO4. Okay, let's do the last one. 15.6 moles, a little extra bump in the M, of calcium hydroxide. And we're going to moles of calcium sulfate. Okay, so moles of calcium hydroxide on the bottom. Moles of calcium sulfate on top. 3 and 3 for our coefficients, so that means we get 15.6 moles of calcium sulfate for our answer. 15.6. Now, it's really important that you always show your work. Even though some of these are more simple, this is going to be one step in bigger problems in the future. So you want to make sure that you're always showing your work, because if you accidentally flip some numbers or something like that, I can see, oh, it was just a little error. I can take off a point. If you don't show me any work and you don't get the correct answer, I can't give you any points whatsoever. And also, I don't know what you did and didn't understand. So it's really hard to help me help you learn from any mistakes that might happen. So let's take care and show work. And if you're not sure how to show your work on Blackboard in a quiz or a test, there's a video in the FAQ section. So make sure you check that out.